Hello everyone and welcome. Have you ever wondered about a chemical reaction where the liquid everything is dissolved in is also one of the main reactants? It sounds a bit like the stage also being one of the main actors. In organic chemistry, this happens all the time, and we have a special name for it, solvolysis. Today, we're going to break down exactly what solvolysis is, how it works, and look at some common examples. Let's start with the name itself. Solvolysis comes from two parts, solvo, which refers to the solvent, and lysis, which means to break or split. So, solvolysis is a reaction where the solvent molecule breaks a bond in another molecule, the substrate. In simpler terms, the solvent acts as the nucleophile. This is the key takeaway. In a solvolysis reaction, your solvent is your nucleophile. These reactions are typically a type of nucleophilic substitution, and most often, they follow an SN1 mechanism. Why SN1? Because most common solvents, like water or alcohols, are weak nucleophiles. They aren't strong enough to just attack a substrate and kick out a leaving group directly. Instead, they wait. The reaction usually happens in two steps. First, the leaving group on the substrate leaves on its own, forming a carbocation intermediate. This is the slow, rate-determining step. Second, a solvent molecule, which is all around, quickly attacks the positively charged carbocation. Often, there's a final, fast deprotonation step to give a neutral product. A classic example is placing tert butyl chloride into water. Water is the solvent. First, the chloride ion leaves, creating a stable tertiary carbocation. Then, a water molecule attacks the carbocation. Finally, another water molecule acts as a base and removes a proton from the attached water, leaving us with tert butyl alcohol. We can even classify solvolysis reactions based on the solvent used. If water is the solvent, we call it hydrolysis. If an alcohol like methanol is the solvent, it's called alcoholysis. If ammonia is the solvent, it's ammonolysis. And if acetic acid is the solvent, it's acetolysis. The rate of solvolysis is heavily influenced by a few factors. First, the stability of the carbocation is crucial. That's why tertiary substrates react much faster than secondary, and primary substrates rarely undergo solvolysis. Second, the solvent's polarity matters. Polar protic solvents like water and ethanol are excellent because they can stabilize both the leaving group anion and the carbocation intermediate. So, in summary, solvolysis is a fundamental reaction where the solvent steps up to be the nucleophile, typically in an SN1 fashion, leading to substitution. Thank you so much for watching. If this explanation helped you understand solvolysis a little better, please hit the like button and consider subscribing to the channel. Your support is what allows us to keep making these educational videos. If you have any questions or want to suggest a topic for a future video, please leave a comment down below. See you next time.